Hello everyone, welcome back. We already studied what are rational numbers in the previous class. Today we shall look into comparison of rational numbers. So first let's look how to compare between two rational numbers. The first case, they should be in the standard form, that is p by q. You remember them, right? And both these rational numbers are positive. Let us drop some numbers on our board. 24 by 27 and 5 by 6. To compare them, multiply the numerator of the first number to the denominator of the second number and write it to the left. So 24 into 6 is 144. Now multiply the numerator of the second rational number to the denominator of the first, then write it on the right. So 5 into 27 is 135. You know that 144 is greater than 135. Hence, 24 by 27 is greater than 5 by 6. Now note that the writing in left and right for those I already mentioned matters. Don't change them. Now let us look for another technique which is quite common. That is by equalizing the denominator, for which we need the LCM of the denominators here, 27 and 6. Both can be divided by 3. That gives us 9 and 2. Most of us continue it until you get 1, but really that's useless. For LCM you divide as long as you have at least come se come 2 numbers with a common factor. If you don't have 2 numbers for a common factor, you stop the division and you can get the LCM directly. Now here the LCM of 27 and 6 is 3 into 9 into 2, which equals to 54. Now look at this 3 and 9. Their multiplication is 27. So the remaining 2 should be multiplied to the denominator 27. This 2 must be multiplied to the numerator 24 also. So that equals to 48 by 54. Similarly, 3 and 2 gives us 6, which is the denominator of our second fraction. Thus, the remaining 9 must be multiplied to the denominator 6 to make it 54. And also the numerator giving us ultimately 45 by 54. And now 48 is greater than 45. Therefore, 48 by 54 is greater than 45 by 54. And therefore, 24 by 27 is greater than 5 by 6. Hence, we place the greater than sign out here. Next, if both the rational numbers are in standard form but both negative. Earlier we did for positive, this time negative. I am taking the numbers that I took earlier to avoid extra but similar calculations. Before we move, let's first understand a few things about the role of negative sign in rational numbers, and it's quite important. Check the number minus 24 by minus 27. The negative sign is above and below the horizontal bar, right? Hence, is this number negative? Now recall the rules of division in integers. Also the multiplication thing. You can cancel those negative signs because they represent the multiplication of minus 1. Hence on cancelling we get 24 by 27, which is positive. Now look at the next number. You have a negative sign to the left of the horizontal bar. You can shift the sign either to the numerator or the denominator, and we are shifting to the numerator. However, you have a negative sign on the denominator also, and hence both of them together, just like above, becomes positive 24 by 7. Now this time the negative sign, one before the fraction and one on the numerator. Shifting the 1 to the left to the numerator, we have minus of minus 24 by 27. And you know what happens if there is a negative sign before the bracket. The sign alters and becomes positive. And we get positive 24 by 27 in this case too. Let me remove this fixed number and use variables like P and Q, and that means whatever the numbers be, if there are two negative signs or even number of negative signs, your rational number becomes positive, not negative, right? So now look at these. Minus P by Q equals P by minus Q equals minus of P by Q. You can see that the minus sign can change places. Once in the numerator, then denominator, then again before the fraction. But in each of them, how many negative signs are there? 1, right? So whenever there is 1 or odd number of negative signs, the rational number is negative. Now back to comparison. You have done for positive same technique except one, that is 144 is greater than 134, but since both are negative, hence it's less than. Now note that I wrote both the numbers after multiplication as negative because minus of 24 by 7 can be thought to have minus with the numerator, as you just learned a minute back. So minus 24 into 6 is minus 144. Same goes for minus 135. Like the positive case, you can also do using LCM, but do not forget to shift the negative sign to the numerator, and that's compulsory. If you shift it randomly, then things get a bit confusing sometimes. Hence I say to shift the negative sign to the numerator for comparisons only. Now then it's all same, and you can see the solution here. You can pause it and see the entire solution, which is same as that of the positive case, only the signs alter. Now the next case, two rational numbers, one positive and one negative, and this is the easiest of all. Why? Because all negative numbers are less than 0, and that's less than all positive numbers. Hence minus of 24 by 7 is less than positive number 5 by 6. If we make positive 24 by 7 and negative 5 by 6, then the sign alters accordingly to match the positives greater than negatives. Now another way where the rationals have same sign, but one is proper and the other is improper. This time also we are taking the same number, again 24 by 7. 24 by 7 actually gave me some pizza treat to advertise it. 5 by 6 didn't, इसलिए मैंने उसको उल्टा लटका के 6 by 5 बना दिया. No, just kidding. Anyway, this is also very easy because all proper fractions are less than 1, and that's less than improper fraction. We have already studied them, and hence the proper fraction 24 by 27 is less than the improper fraction 6 by 5. If both were negative, then signs would reverse. 24 by 27 is less than 6 by 5. Thus, minus 24 by 27 is greater than minus of 6 by 5. Now, in these two examples, I just altered the place of proper and improper fractions, and hence signs also changed. Pause and you can follow the results. Now we shall compare between 3 or more rational numbers. For this we shall follow only a single technique. However, whatever you studied till now, if you use smartly, that will lessen your hard work. Smart work is better, right? So we have various types of rational numbers, 5 of them here. We are excluding the decimal types that you are going to study in the next chapter. The first step is to write them in standard form, P by Q, where P and Q are integers. Also, Q is not equal to 0. So 3 can be written 3 by 1. 11 by 14 is already in standard form. Minus of 5 by 3 is written same, but we shall consider the negative sign for the numerator 5, right? 23 by 12 stays same. The mixed fraction 3 and a half becomes 3 into 2 plus 1 equals 7 by 2. Then we use the LCM technique. But then we use the technique of equalizing the denominator, and for that we need to take the LCM. But before going to the method, I need you to follow me this time. I shall tell the answer without doing this algorithm by simply observing the numbers and using random rules of mathematics that you already know. Firstly, look into the first line of the numbers. Look at the third number, minus of 5 by 3. Only this is negative, hence it have to be the smallest. Next, 11 by 14 is the only proper fraction and hence is smaller than the rest. But it will be greater than the negative number, hence it will take the second place. Now 23 by 12. 12 into 2, you know that is 24. The numerator is less than 24. Thus, this improper fraction is less than 2 for sure. But the remaining two numbers, 3 and 3/2, is more than 2. Right? Hence, the third place will be taken by 23 by 12. And obviously, 3 is less than 3.5. So, my final result, minus of 5 by 3 is less than 11 by 4 is less than 23 by 12 is less than 3 is less than 3.5. Now you verify it at the end of the solution. As you saw, knowing rules made me answer it without doing major calculations, and that's what we say shortcuts. So know the rules and use them whenever possible. That will make you an expert from a mediocre. Anyway, we need to find the LCM of these denominators. We can exclude writing 1, right? So 14, 3, 12 and 2. Now 2 divides 3 of them. 14, 12 and 2. This gives us 7, 3, 6 and 1. That 3 remains same because 2 doesn't divide. You know that for LCM. And as I told you, as long as two numbers have common factor, continue dividing. Here 3 and 6 still have a common factor, 3. So dividing by 3 gives us 7, 1, 2 and 1. We don't have any more numbers which have a common factor other than 1. So the LCM of those denominators is 2 into 3 into 7 into 2, which is equal to 84. So making the denominator 84 for each rational gives us the first one quite easily, as 1 into 84 is 84, and hence it becomes 3 into 84 by 1 into 84. In the second fraction, the denominator is 14. Here 7 and 2 makes 14. So the product of the remaining numbers, that is 2 and 3, which is 6, must be multiplied to the denominator 14 to make 84, and same for its numerator. The next rational have denominator 3, so the remaining 2, 7 and 2 makes 28, hence 28 must be multiplied. Similarly, pause and do for the other two denominators 12 and 2 and check if you are right or wrong. Multiplying them, we get 252 by 84, 66 by 84, minus 140 by 84, 161 by 84, and finally 294 by 84. Now, since the denominators are equal, we can easily compare the numerators. Minus 140, the smallest, takes the first place. Next 66, then 161, and then 252 moves here. 294 stays last, and this is in ascending order, that is smaller to bigger. Some special cases now. Firstly, we have an integer and a mixed fraction. Both are rationals, we know, right? Let's take a few examples. To compare them is easy if you know what are mixed fraction, which is written as quotient which is written as quotient and remainder by divisor. This quotient is the whole part or the integral part, and the remainder by divisor is the proper fraction part. We need to look for the whole part only in most cases. For 5 and 3 by 4, 5 is the whole part. Take the whole parts of the first example and we have 14 and 5. Clearly 14 is greater than 5 and hence 14 is greater than 5 and 3/4. The next one have 2 and minus 3. So positive negative numbers, great. 2 greater than minus 3. Directly, you don't need to do anything else. The third one is different and you should take care to notice this one, because both of them have the same whole part. Hence, in this type of cases, consider the proper fraction part also. And if you bring that half, you can clearly say that 2.5 is greater than 2. You don't need to make them improper fractions, then equalize the denominator and then compare. You can directly say that 2.5 is greater than 2. Or to simply put, if whole parts are same, the mixed fraction is always greater than the integer. Only if the signs are positive. And if the signs are negative, then things will be opposite simply. It will be less than. And the last one, what shall it be? Less than or greater than? You verify it yourself. And also ask yourself whether you know the reason or not. That is why it is less than or why it is greater than. The next special case is when you have improper fraction and mixed fractions. We already studied that improper fractions can be written as mixed fraction, as quotient and remainder by divisor. The quotient, which is the whole part or integral part, is all that we need to compare. The proper part shall be needed only when the integral parts are equal. Hence the first one, 4 by 3 is 4 and 2/3, and we have 5 and 3/4. Clearly the whole part 4 is less than 5. Thus we put the less than sign here and also here. The second one is very easy. Positives greater than negatives. Great again. So no conversion required. The third one, different one, 23 by 11 becomes 2 and 1 of 11th. You see that the integral parts are equal. That is 2 in both cases. Thus, we need to compare the proper fraction part now. Observe the number and you can directly say which one is greater. Why? You need to recall when numerators are equal, then the fraction which has a smaller denominator is greater. We have studied that earlier. And here the numerator for both is 1 and the denominator is 2, and denominator 2 is greater than 11. Thus 1 by 2 is greater than 1 by 11. Thus 1 by 2 is greater than 1 by 11, and thus 2.5 is greater than 2 and 1 by 11. The last one is your job to do. The last type of comparison, we need to look at decimal numbers. Yes, it's new for you, and hence we shall study it broadly in a different video for the next chapter. Let's take an example to understand what is decimal numbers. 345.125 is a decimal number. I am saying 125. I am not saying 125. The number before the decimal, we say it as a whole, 345, 345, or whatever it is. But after the decimal, we call them as digits, 1, 2, 5, that way. This point is called the decimal point. The number to the left of this point is the whole part or integral part, same as 345 and 1 by 8, which is fractional form of this decimal number only. And the number including the point is the decimal part, which is equivalent to the proper fraction part 1 by 8. So as you can see, the mixed fraction is only written in the form of decimals. However, all decimals are not rational numbers. Mixed fractions are always rational numbers, but all decimals are not rational numbers, and we will see that. Some more examples of decimal numbers are 1.5, 2.08, 11.33, 6.7 bar, 1.333 continue to infinity, that is 3 never ends, and 1.1, etc. You need to remember the second point and the third point also. It's quite important. Every rational number can be written in the decimal form, but every decimal number cannot be written in the form of p by q. That means every decimal is not a rational number. The decimals which are both non-terminating and non-repeating, like 12.01, 001, 0001, 00001, continue to infinity. This number continues on, and hence it's non-terminating. It is even non-repeating because after every one the number of zeros increases. Look into the next number, 3.141695991986691693692168. This three dots says that it continues, and you can see that no number repeats. Now let's take another example. Here too the numbers after decimal don't end and does not repeat. And yes, we shall study about decimal in a different chapter, not now. So thank you so much. Bye bye.